So this problem I'm doing has two parts. So let's say we have a baseball diamond, right? Uh, it's basically a square. This is not a great square, but the side length is, let's say 100 feet, okay? A batter hits the ball, right, and is running from home base to first base. He's running at a speed of 20 feet per second. And so then my question is, at what rate is his distance from second base changing when he is 30 feet from first base? So when this value x is equal to 30, what is the rate of the distance from second base to the ball player, right? So he originally starts at home base and he's traveling this way, right? So to get a better idea, this is a square, right? And then so it's like this, right? This is second, this is first, second, home. And what the person is doing, he's running from home to first, and you want to calculate the distance. So what we see here is a right triangle. And this right triangle, let's say D is the distance. So this part is X, and this is Y, right? So let's do just the entire area is X. So D squared equals Y squared plus X squared. That's Pythagorean theorem, right? So that also gives us the derivative function. So 2d d prime equals 2y y prime plus 2x x prime. Everything in this equation has 2, so we can divide everything by that. So it's just d prime equals y prime plus x prime. At this moment, what's happening is that x equals 30 because he is going from here to, let's say here, and x equals 30. So from here to here, x equals 30, y is equal to 100, because as we said, the side of the base is 100, and we need to get d. So for this equation, what we need is d, we need to get d, and we're looking for d prime. We need to get, we have x, and we have x prime, because at the beginning, the runner is running at 20 feet per second. So we can ignore y times y prime. Why, you might ask? Because y, we know, is the side length, which is 100. However, y prime is the rate at which that side is changing. It's not changing because he's not running from first to second base. He's only running from home base to first base. So this entire side is not changing. So y prime equals 0. So, right, so let's plug in the values we know. So d prime equals 0 plus 30 times 20. So d prime equals 600. Let's write that out. So now we need to get d prime, we need to get d. Well, d is pretty easy because we can just use Pythagorean theorem. D squared equals y squared plus x squared. So in that case, d squared equals x squared is 30 squared plus 100 squared. Right, so it's square root 900 plus 10,000. And let me get my calculator. That value is 104,403. So from that we know D equals 104.403, right? Or 104.4. So we have this equation, right? So we can plug this, we can substitute it back into our derivative equation. So we get, so D prime, to speed it up, equals 600 divided by 104.403. Therefore, D prime is equal to 5.75. So the rate at which this the distance from second base to the batter is changing is 5.75 feet per second. So then my next question is, right, how fast is his distance changing from home plate instead if he is halfway between first and second base? So it's very similar to the first question I asked, but the difference is instead of from second base to him running from home to first, it's home from first to second. So what we know is that he is halfway between first and second. So that means this value of, let's say x again, is equal to 50, right? And then it's a very similar question to the first one. So in this situation, that's a rectangle, but the idea is there. He is halfway between first and second, right? So that means his is 50 and this is 100. Okay, so the equation is very similar. It's Pythagorean theorem. So d squared equals y squared plus x squared. That's set. This says x and this is y. If for simplicity, we can just solve for x prime, right? And then let's just get this value real quick. So d squared equals y squared plus x squared. In this situation, d equals square root 50 squared plus 100 squared. And what does that equal? That's equal to 111.80. 111.8, right? So in the same, it would be a similar equation, d prime, because we solve it from 2d prime equals 2y prime plus 2x prime. And it's, again, very similar to the first problem because one side is not changing. So we said, let's say this is y prime equals 0 because this side's not shrinking or increasing. It's solely this x value, and then that's impacting the distance right now. So it's just d prime equals 0 plus x prime. D equals 111.8. D prime equals x prime. Let's just use the same number. Let's say he's running at the same speed because he's just really good at running. His rate, x prime, it's going this way, is 20 feet per second, right? So he's at 50 feet this time. So that's equal to 50 times 20. So d prime equals 1,000 divided by 101.8. And what do we get? We get 8.94 feet per second. So in this situation where he's halfway through, the distance that's changing from the home base to where the runner is running is changing it at this rate.